Welcome to the lecture on composition. The aim of this lecture is to show you how you can place or arrange elements within your artwork to create visual harmony. We're going to look at various ways to achieve this, like the rule of thirds and the golden ratio, etc. But let's start with the golden ratio. So what is the golden ratio? That's a very good question. Some say it was discovered by a Greek sculptor and mathematician in 500 BC, and others say it was discovered in 300 BC. I have no idea how they find stuff like this out, so let's just say it's old and leave the history lesson at that. So what is the golden ratio? Well, it's this. 1.618 recurring, but usually it gets clipped at this number, 1.618. Also, it's described like this. A plus B is to A as A is to B. To explain that further in more simple terms, let's say the length of line A plus the length of line B equals another longer line called line C. So the value of line C is the exact same ratio to A as line A is to line B. When I first read that, my head exploded. I was like, what? And I found it much easier to visualize it. I'm not the best mathematician anyway, so when my lecturers started saying stuff like that to me, I started to shut down. And I don't want to bore you to death either. I'm going to show you in a visual way because that's what we arty types prefer, right? Right. I'm going to draw lines, create rectangles and shapes, pretty simple stuff. There is a little bit of math, but nothing I'm sure you can't handle. First, let's create a golden rectangle. Using the golden ratio number above, draw a vertical line 500 pixels long. Be precise, and I mean be precise. It must be 500 pixels long. We'll call this line A. Pause here to do that, and I'll wait. Okay, did you do it? Hopefully you did. So that line is going to be the long side of our rectangle. Okay, here comes a little bit of math, but don't worry, you can do it. Use a calculator and divide 500 by 1.618, the golden ratio number. And you get 309.02348 ... We always round this number up or down to the closest whole number, which in this case is 309. Now draw a horizontal line 309 pixels long, precisely. Once you've done that, we'll call this line B. Pause again, and I'll wait for you to do that. Okay, now join the two lines to form a corner like this, but ensure the vertical line overlaps the horizontal line at the corner. You must overlap to keep both lines the exact same length, both horizontally and vertically. If you don't overlap, then one side will be longer than it should be, and that is not good. Select the two lines and duplicate them. Rotate them 180 degrees. Again, join them at the corners, ensuring they overlap to retain the correct length and width. Now merge all four lines together. And there you have it, a golden rectangle. It doesn't have to be this size, it can be any size, but it's important that the width-height ratio is correct, i.e. 1.618. We're now going to create a square that is the same width and height as line A of our rectangle, 500 pixels. Draw a square that is 500 by 500 pixels. Again, pause the lecture here to do that. I'll wait for you. Okay, good. Now join the square to the rectangle like this. Make sure it connects precisely. Now, curiously, if you add 500, the top of your square, to 309, the top of your rectangle, you have 809. Now if you divide 809 by 1.618, you have 500 again. So this is what they mean by A plus B is to A as A is to B. I hope that all makes sense to you. If not, just go back and just go through that again. If you have any questions about that little section, just let me know, because it's quite important. So what has all this math got to do with art? Well, I'm now going to show you. But to do that, we need to create another rectangle at the same ratio as the first one we created. Then flip it on its side so it fits inside the first rectangle. But we must use the golden ratio numbers above to create it. So the short side of our existing rectangle is 309. This will become the long side of our new rectangle. And the short side will be, yes, you guessed it, 309 divided by 1.618, which is, rounded up, 191. So that is the length of the short side of our new rectangle. Create the rectangle 309 by 198 in the same way as you did before. Now lay it on its side and place it inside the first rectangle at the top, like this. Make sure the lines overlap exactly, and you'll notice that it fits perfectly. Magic math, that's what I call it. Now we need to do it again, but this time we'll rotate the new rectangle so it's standing vertical. You already know the height, which is the length of the shortest side of the previous rectangle, 191. To calculate the width, you also know the math. 191 divided by 1.618 equals 118, rounded up. Pause the video and create the rectangle, and I'll wait here. Okay, have you done that? Great. Now place it inside the previous rectangle to the left side like this, and you'll see it's another perfect fit. You should also notice we're moving in a spiral rotation with each rectangle in this direction through the shapes, and that's important. Okay, so we need 5 more rectangles to make a full house, each one getting smaller and calculated in the same way as before. I'm not going to bore you by letting you sit here and watch me do it. So this challenge is for you. Pause the video and create 5 more rectangles, each one getting smaller than the last, using the golden ratio number above, just as before. Pause now, I'll wait, you go ahead and create the rectangles and then come back and continue the video once you've done it. Okay, hopefully you have your 5 rectangles all calculated in the same way as we did before. 5 rectangles that look like this. 118 by 73, 73 by 45, 45 by 28, 28 by 17, and finally 17 by 11. Now fit them inside each other as we did before, starting with the larger one, moving them around in a spiral direction like this. And this. That's it. Move them around. Fit them nicely. They should all fit perfectly if your math was correct. Okay, if you've done it right, all your rectangles should look like mine, and you'll get this exactly. Okay, if you've done it right, all your rectangles should look like mine, and you get this exactly. This combined together is a tool that you can use as a composition guide when creating your art. At this point, be sure to save your image because we're going to use it in a later lecture. So, how can you use this in your art? The position of the smallest rectangle is sometimes referred to as the power point, a position in your image that the viewer will be drawn to. Why? Well, the golden rectangle is said to be the most beautiful rectangle and is believed to be most pleasing to the eye. The Greeks realized this long ago, before modern psychologists tested it, and is why they used the golden rectangle and golden ratio in their architecture. The focal point in your art that sits at the power point doesn't have to be exact. The area around it is said to be called the cradle zone, so provided it's close, it'll have the desired effect. But you can see in these images, even the old masters used it too. Also, you can rotate or flip this guide to suit your image. Whether it's landscape, portrait, it doesn't matter, it will still work. Over time, people have modified it, adjusted it, but it's still based on the golden ratio. This is called the phi grid. The largest golden rectangle we created first is copied to the left of the square, and two lines are drawn horizontally. The cross points of the grid are your power points, and all the vertical lines are often used as focal areas for composition. The modern day version of all of this is called the rule of thirds, mostly used in photography and film, and of course video games. This is basically three golden rectangles placed side by side, and then the space divided equally vertically, like this. It's very similar to the phi grid, but divided equally, thus thirds. And the cross points again are your power points, and the vertical and horizontal lines are used for composition and will draw the viewer's eye. Once you realize and understand it, you will see the rule of thirds in images everywhere. But the guide is also embedded in lots of hardware and software too, in cameras, on your phone. You can set it up in Photoshop, etc., and it can be used to greatly improve the composition in your work. As we progress through the course, we'll be using it when we start to create our concept art, and also consider it when we start to create our actual 3D scene. Also remember, these are only guidelines, not a rule of thumb. You don't have to use it, it's entirely up to you, but it's basically a tool for you if you want some help. Please don't get bogged down doing a bunch of math before every drawing. It's supposed to be fun and creative, and once you start to use it, you won't even think about it, it'll become second nature. By all means, research further. As a challenge, go onto Google and search phi, PHI, and the golden ratio. It can be heavy reading, but it's incredibly interesting once you get your head around it. So have a read and have fun with it. I hope it helps. Let me know in the comments section if you feel it needs more explanation, and I'll do my best to get back to you. So next, we're going to move on to perspective. So I'll see you there.